vastness of the universe, time ticks away on a cosmic clock, marking scientists tell us about 13.8 billion years since the Big Bang. But this video delves into the intricate world of proteins and challenges whether evolution and natural selection could produce even a single protein in the history of the universe. Today we embark on a journey to explore the enigmatic realm of proteins. We'll draw wisdom from Dr. Doug Axe's book, Undeniable, and Dr. Stephen Meyer's scholarly works to navigate our inquiry. And for those eager for a playful dive into Christian education, our board game awaits you in the description section below, or visit welcometotruth.com for more Christian education. Proteins are the building blocks from which the cell is primarily constructed. Proteins do the work of the cell, carrying out chemical reactions necessary for the cell to function. But what are proteins made from? Well, proteins come from tinier bits called amino acids. The amino acids follow sort of a treasure map given to them from our DNA to stick those amino acids together in just the right way to build certain proteins. So each protein is made of a long string of amino acids whose sequence or order in the string is specified by its coding sequence in its DNA. So the DNA tells the amino acids how to come together to build proteins which construct our cells. And the DNA is made of nucleotide bases A, C, T, and G. Find out how DNA points to God in that video. So nucleotide bases' precise arrangement provides the instructions for building the proteins and protein machines that cells need to stay alive. Are you with me so far? Proteins are like the Lego blocks of our cells, building them up and making them work. Again, these tiny protein workers are made from even tinier parts called amino acids. These amino acids link up in a special way called a peptide bond to form a chain. So these amino acids link together to form peptide bonds, and these peptide bonds assemble into something called polypeptides. So you have these polypeptide chains of amino acids. If one of these polypeptide chains folds into a specific shape that enables it to perform tasks within the cell, it is called a protein. Only when folded into a specific 3D structure do these polypeptides become functional proteins. Now, most amino acid arrangements produce chains that do not fold into stable structures at all. Relatively few will become functional structures or proteins. So amino acids are the molecular units that comprise a protein. Let's go a step further. Now, these proteins are very picky. They only work with left-handed amino acids. What do I mean by that? In nature, every amino acid found in proteins, with one exception, has a distinct mirror image of itself. There is one left-handed version, or L form, and one right-handed version, or D form. These mirror image forms are called optical isomers. Now, functioning proteins tolerate only left-handed amino acids. Yet, in amino acid production, the right-handed and left-handed isomers are produced with roughly equal frequency. Okay, now that we know something about how proteins are created, we will show you the implications of forming even a single protein by chance, thus taking out chance as a possibility for how life, and in this case proteins, have formed. For a protein to work, it needs to fold up in a special way, almost like origami. Proteins do not just display a specificity of shape, They also display a specificity of arrangement. Those structures or shapes determine what function, if any, the amino acid chain or potential protein can perform in the cell, whether as an enzyme or a structural component or a machine for processing information. A protein's fold is a distinctive, stable, complex 3D structure that enables proteins to perform specific biological functions. For every functional gene or protein fold, there is a vast, exponentially large number, about 10 to the 77th, of corresponding non-functional sequences through which the evolutionary process would need to search. When I say the evolutionary process would need to search, I am referring to the blind process of natural selection, which is how Darwinian evolutionists say is the way that all complex life came into being. If you don't know what natural selection is, check out that video there. So with all complex life, Darwinian evolutionists would tell us that it all came about through the mechanism of natural selection through random mutations, so by chance. But are there enough chances? Are there enough moments? Enough seconds since the Big Bang 13.8 billion years ago to form these proteins? No, there are not. The average protein is about 300 amino acids in length. More precisely, 267 for bacteria and 361 for eukaryotic proteins. We talked about how the function of a protein molecule depends on its 3D shape, which is determined by how the linear molecule folds. As I said, proteins make up cells. Most functional proteins are made of hundreds of amino acids. Dr. Doug Axe worked with relatively shorter proteins of about 150 amino acids. Yet even this short protein represents one sequence among an astronomically large number of other possible sequence combinations. To come up with just a 150 amino acid protein would require one chance out of 10 to the 195th power. Now, we talked about how all amino acids must form a chemical bond known as a peptide bond when joining with other amino acids in the protein chain. And that if the amino acids do not link up with another via a peptide bond, the resulting molecule will not fold into a protein. With every amino acid addition, the probability of it forming a peptide bond is roughly 1/2. Once 4 amino acids have become linked, the likelihood that they are joined exclusively by peptide bonds is roughly 1/16 or 1/2 to the 4th. The probability of building a chain of 150 amino acids in which all linkages are peptide linkages is 1/2 to the 149th, or roughly 1 chance in 10 to the 45th. Yet as we mentioned, functioning proteins tolerate only left-handed amino acids. Yet in amino acid production, the right-handed and left-handed isomers are produced with roughly equal frequency. Starting from mixtures of D forms, remember that's right-handed, and L forms, left-handed, the probability of building just a 150 amino acid chain at random in which all bonds are peptide bonds and all amino acids are L form is roughly 1 chance in 10 to the 90th. In his experiments, Dr. Axe found that a random process producing amino acid chains of this length would stumble onto a functional protein only about once in every 10 to the 74th attempts. These odds are worse than the odds of finding a single marked atom out of all the atoms in our galaxy, about 10 to the 65th, via a blind and undirected search. Let's take it a step further. The probability that a 150 amino acid compound could be assembled by random interactions in a prebiotic soup to be a functional protein can be made by multiplying the three independent probabilities by one another. The probability of incorporating only peptide bonds, 1 in 10 to the 45th, times the probability of incorporating only left-handed amino acids, 1 in 10 to the 45th, and the probability of achieving correct amino acid sequencing using Dr. Axe's 1 in 10 to the 74th estimate. So that's 10 to the 45 plus 45 plus 74 equals 1 chance in 10 to the 164th. The odds of getting even one functional protein of modest length, 150 amino acids, by chance from a prebiotic soup is no better than 1 chance in 10 to the 164th. That's just for one protein. More typical proteins have hundreds of amino acids. The typical RNA polymerase has over 3,000 functionally specified amino acids. In 1983, distinguished British cosmologist Sir Fred Hoyle calculated the odds of producing the proteins necessary to service a simple one-celled organism by chance as 1 in 10 to the 40,000th. Dr. William Dembski has calculated that there has been roughly 10 to the 16th seconds since the Big Bang. So Dembski used this information to calculate the total possible number of events that have occurred since the Big Bang. Would you like to know what he came up with? Dembski did this by multiplying the three relevant factors together: the number of elementary particles in the observable universe, 10 to the 80th, times the number of seconds since the Big Bang, 10 to the 16th, times the number of possible interactions per second, 10 to the 43rd. His calculations fixed the total number of events that could have taken place in the observable universe since the origin of the universe at 10 to the 139th. Now, if you need 10 to the 164th chances to get one functional protein of modest length, 150 amino acids, then you literally don't have enough time to render the chance hypothesis possible if you only have 10 to the 139th events since the Big Bang. So what's your take? Do you still believe it all just happened by chance? Check out this video on the fine-tuning of our universe and how it points to God.
These videos take hours and hours to make. Boost my energy up by buying me a coffee in the description section of this video. Thanks so much.
And if you want to make educational videos like this, check out the Pictory link below in the description section. We'll see you in that video over there.